All right, we're looking at 0654 paper 6 from winter 2019. Two questions. It's question 5 that we're looking at. It's first of the physics ones. You're looking at a piece of modelling clay, which you should be aware is soft, and that's why it has this kind of irregular shape. That's going to be useful for later. Okay, first thing that you asked to do, really, really simple. You just asked to measure the values of h, l, and w. That's the height, length, and the width. Okay, and you obviously need to use a ruler for that. Now, what you will have found is if you printed this out, as I've found, the values on the mark scheme are slightly different to the values that you get. And I might have sent you crazy. Don't worry about it. It happens to everybody. This is because there's a slight change in the formatting when they do the exam papers and they do the online version. Don't worry. You'll find that your values should be a little bit smaller than the ones that were on the mark scheme. Okay. Obviously, we should be placing our ruler and simply measuring this way, okay, using the ruler in a sensible way, okay, following the instructions which are to give our values to the nearest 0.1 centimeters, okay? So please don't give me anything in between. Now, the reason I mention that is because there is one value here, okay, let me just move this along, which was W for me. I'm just making sure you can still see this on the screen yet. You can just about do that. Okay, now what I find is that when I measure W, it kind of comes somewhere in between. Okay, somewhere between 3.2 and 3.3. Now, the temptation there, all right, is to say, well, 3.2, 3.3, that's 3.25. The question has specifically asked you for this to be to the nearest 0.1, and so therefore you must give it to the nearest 0.1. So for me, when I looked at that, I noticed it looked just about closer to 3.3, so that's why I went with that. Now obviously, those numbers are different to the ones online. That's on the mark scheme, that's fine. Don't worry about it, okay? In the real exam, you wouldn't have that problem, all right? Obviously, that takes an effect on our values of calculating the volume. Well, you're just taking your L, your W, and your H and calculating them together. Now, a few things to pay attention to is that if you did make a mistake here, then you wouldn't lose the mark here as long as you've done the working correctly. Okay, so Cambridge punishes you once for each mistake and once only. You get something called ECF, error carried forward. It means if somehow I measured 4 there, and I put my 4 down here, then I did everything else correctly, you wouldn't be punished twice. Don't worry about that. Okay? You're asked one reason why the value of the volume is not accurate. Okay? Every time you ask for not accurate, please don't say that the student has done something wrong. We've got to think about the limitations of the process. The limitation of the process here is that this equation we've used is the equation of the volume of a regular shape, i.e. a cuboid. Yep. And when we're looking at a cuboid, cuboids have nice straight lines. We'll see another example of this in another question. They have nice straight edges. Well, this thing clearly does not have straight edges. It's got an irregular shape, which means our values of L, W, and H are all going to be wrong or inaccurate or incorrect, and therefore this value of the volume is going to be incorrect. If L, W, and H are wrong, then V is obviously going to be wrong too. How do we rectify this? This is when we use this thing, the displacement method. Now this may be one that you've forgotten about. It was a while ago that you may have learned it. The idea of the displacement method, illustrated here. You've got a shape, and you want to know the volume of it. Well, if I've got some water, if I measure the volume of that water, I then put this thing in there. Obviously the level of that liquid is going to rise, and there's going to be an increase in the volume. I have a new volume and an old volume, and if I find the difference between the two, then I can know the volume of this object that I put in. This is also known as Archimedes' principle. It's the eureka moment idea, whereby when Archimedes was trying to measure the volume of a crown, he used this displacement method to determine whether the material was gold or another metal. Okay, so let's go on to these are just simple measurements and calculations. All right. We're then looking at the rest of the experiment. The point in this experiment was to measure density. We've got the volume. We need to know the mass now, and we use the mass that we use is this bit, is this method here, where we're going to use a balance essentially. We've got our clay next to a known mass. You don't know the value of the mass, don't worry about it. And we're going to put that on there and measure its mass in this way. First thing you're asked to do, very simple measurement. You're asked to, firstly, to measure this distance x, and you're kind of zooming in to the ruler and seeing the scale here. This is 68, this is 69. We've got 10 divisions between there. Each one of that represents a millimeter. 68.1, 2, 3, 4, 5, and then 6. So that is 68.6. We measured the distance from 68.6 to 50.0. Well, just take 2, minus them, and you get 18.6 there. Okay, so there's 1 mark for identifying, for getting this correct, and then 1 mark for getting this. Okay. Over the page, we're then asked to do some calculations with that number. Again, nice and simple. They just give you the value of the numerator here. You've got the value of x, which is your 18.6 from the previous question. Okay, 1750 divided by that gives you 94.8086. In this case, you aren't not asked to give a certain number of significant figures. However, I would always go for 3, go for 94.1 over 94.8086. Okay. All right. We then said, why is this inaccurate? Why would our measurement of x be inaccurate? And again, this really links back to our irregular shape. It's modeling clay. And we're saying that we said originally that our x was this position of the center of our object. Well, we've got an irregular object, and its center is very difficult to locate. So the fact that we've highlighted x as a distance from the 50 centimeter mark to the center of the object is a questionable statement. It is difficult to locate the center of this object, meaning that x will be inaccurate. Notice I am using the words inaccurate. I'm not using bad, I'm not using wrong, I'm using inaccurate. Try and use less emotive words when you're using this. Last one, we're told the equation for density. We've got our mass, we've got our volume. All we have to do is take a ratio. Okay, I hope that's clear.